Today we're going to talk about adding and subtracting rational expressions and simplifying complex fractions. So by the end of this video, you should be able to find common denominators to add and subtract rational expressions, and you should be able to simplify complex fractions. To start, let's go back to elementary school and think about how we add and subtract fractions. So if I have 2/3 plus 2/3, they have a common denominator. So all I do is add the numerators together and keep the denominator the same. It's the same thing when you have rational expressions. In example number 1, we have the same denominator. So all we need to do is add the numerators together and leave the denominator the same. Then we need to double check and see if we can simplify. Since 16/4 simplifies, our final answer is 4/x. We find the domain the same way we did when we multiplied, divided, and simplified. We need to look at the denominator of the original problem, which in this case was 4x, set it equal to 0, and then solve for x. So you would divide both sides by 4 and end up with x equals 0. So our domain will be x such that x does not equal 0. In number 2, we also have the same denominator. So we can just go ahead and add the numerators and leave it over the denominator. Since we can't factor, there's nothing that we can do to simplify. To find the domain, you set the denominator equal to 0 and solve. You get x equals -1, which means the domain is x such that x does not equal -1. In number 3, we are subtracting, but again, we have the same denominator, so we can just go ahead and subtract the numerators and write it over the denominator. You need to be careful when you subtract. Sometimes you might have to distribute the subtraction to the numerator of the second fraction. Since we can't factor either the numerator or denominator, 2x minus 1 over x minus 3 is our final answer. Again, to find the domain, we set the denominator equal to 0 and solve. So we end up with x equals 3, which means our domain is x such that x does not equal 3. Now, sometimes you don't have fractions with the same denominator. So if you have to add or subtract rational expressions with a different denominator, you first need to find the least common denominator, or the LCD. So again, let's go back to elementary school. If we have 2/5 plus 3/4, we want to find the smallest number that has both 5 and 4 as a factor. So that number will be 20. So our LCD is 20. Step 2 says you need to multiply the numerator and denominator of each fraction by the, quote, missing factors. So we want both of our denominators to be 20. So the first fraction needs to be multiplied by 4/4 to make the denominator 20. The second fraction needs to be multiplied by 5/5 to make the denominator 20. You always have to multiply the numerator and denominator by the same thing. That way you make sure you're not changing the value of the fraction. Then we can go ahead and multiply these together. So you end up with 8/20 plus 15 over 20. Then we can go ahead and add. So in this case, we end up with 23 over 20. If we could simplify this at all, we would need to do that as well. So let's take a look at these examples when we are adding and subtracting rational expressions. Our first example is 3 over x plus 5 plus 4 over x plus 1. Our factors, when we're looking at the denominators, are x plus 5 and x plus 1. If we could factor either of these denominators more, we would need to do that. Now we need to go ahead and find our LCD. Our LCD is the smallest possible expression that has both x plus 5 and x plus 1 as its factors, which is just x plus 5 times x plus 1. So now we need to get both of these fractions to have x plus 5 times x plus 1 as their denominators. So the fraction on the left is missing x plus 1, so we need to multiply that on both the numerator and denominator. The fraction on the right is missing x plus 5. So now you need to go ahead and multiply. So in the numerators, we need to distribute the 3 to get 3x plus 3 over x plus 1, x plus 5. Then for the second fraction, you need to distribute the 4. You get 4x plus 20 over x plus 1, x plus 5. Then you can go ahead and add. So we end up with 7x plus 23 over x plus 1 times x plus 5. Since we can't factor the numerator, that is our final answer. When you are trying to find the domain for an addition or subtraction problem, the easiest thing to do is just look at the LCD. Set the factors of the LCD equal to 0. So you end up with x equals negative 5 and x equals negative 1. So our domain is x such that x does not equal negative 5 or negative 1. As you get more comfortable with this process, you might not have to write out every single step that I wrote out on this problem. But to start with, go ahead and write everything out to make sure that you remember to distribute in the numerator and that you get all of the factors correct. Let's take a look at the next problem. We have x minus 3 over x squared minus 9 plus 7 over x plus 3. It's always helpful to factor out the denominators. So we can factor x squared minus 9 to be x plus 3, x minus 3. Now, there are two ways you can do this problem. You can either go ahead and start finding the LCD and multiplying by the missing factors, or you might notice that the first fraction can be simplified. We have an x minus 3 in both the numerator and denominator of the first fraction. So I can go ahead and simplify the first fraction and make this problem a lot easier. So now I'm left with 1 over x plus 3 plus 7 over x plus 3. So my final answer is just 8 over x plus 3. Now, when you go to find the domain of this problem, you need to be careful. Because, yes, after we simplified, our denominator was just x plus 3. But originally, there was an x minus 3 in the denominator. So you need to set both of those equal to 0 and solve. So you get x equals -3 and x equals 3. So our domain is just x, such that x does not equal positive or -3. Let's look at another example. We have 6 minus 5 over x plus 3. Here, it's probably helpful to write the 6 as 6 over 1. So our two denominators are 1 and x plus 3. So our LCD is just 1 times x plus 3, or just x plus 3. So we need to make sure that we multiply the first fraction, the 6 over 1, by x plus 3, the missing factor. The second fraction already has the LCD as its denominator, so we don't need to do anything there. We do need to remember to distribute the 6 to the x plus 3, so we have 6x plus 18 over x plus 3 minus 5 over x plus 3. Then we can go ahead and subtract. We get 6x plus 13 over x plus 3. Remember, when you find the domain, look at the LCD, set that equal to 0, and solve. So our domain is x, such that x does not equal -3. Now let's look at number 7. This one's a little trickier. We have 3 fractions, so we need to find the LCD for all 3 fractions. So we need the simplest expression that has 2x and x squared as its factors. Well, we know we need to have 2 as one of the factors. Then we need to have x and x squared as factors. Well, x is a factor of x squared, so if we have 2x squared as our LCD, 2 is a factor of that, x is a factor of that, and x squared is a factor. So now we can go ahead and multiply each fraction by the missing factors. The first fraction needs an x squared, so we need to multiply both the numerator and denominator by x squared. The second fraction, if you look at the denominator, we already have an x, we need a 2, and another x. So we need to multiply this fraction by 2x. Then the third fraction just needs to be multiplied by 2 over 2. So now we can go ahead and multiply. First fraction ends up being x squared over 2x squared. The second fraction is 4x over 2x squared. Then the third fraction is 6 over 2x squared. So now we can just go ahead and add and subtract. So we end up with x squared plus 4x minus 6 all over 2x squared. Again, when you find the domain, just set the LCD equal to 0 and solve. So we would divide both sides by 2, then take the square root. So we get x equals 0. So our domain is x, such that x does not equal 0. Let's try one more that's a more complicated problem. We have 1 over x plus 1 plus x over x minus 6 minus 5x minus 2 over x squared minus 5x minus 6. Before we find our LCD, we need to make sure that all of the denominators are factored. X plus 1 is factored, x minus 6 is factored, but we can factor x squared minus 5x minus 6. So that'll end up being x minus 6 times x plus 1. So when we find the LCD, we need to make sure that each of those denominators is a factor of our LCD. Since x plus 1 and x minus 6 are factors of x minus 6 times x plus 1, x minus 6 times x plus 1 will be our LCD. So now we need to multiply by the missing factors. The first fraction is missing an x minus 6. So we need to multiply by x minus 6 over x minus 6. The second fraction is missing an x plus 1. So we need to multiply by x plus 1 over x plus 1. The third fraction isn't missing anything. Its denominator is already our LCD, so we don't need to multiply by anything. Now we distribute. We end up with x minus 6 over x minus 6 times x plus 1 plus x squared plus x over x minus 6 times x plus 1 minus 5x minus 2 over x minus 6, x plus 1. So now we can go ahead and combine our numerators. But the one thing to be careful with is that we need to distribute the subtraction to the numerator of the last fraction. So we could rewrite this as negative 5x plus 2. So now when we combine our numerators, we end up with x squared minus 3x minus 4 over x minus 6, x plus 1. So we need to check and make sure that we can't simplify this fraction anymore. So we need to go ahead and factor the numerator. So we end up with x minus 4 times x plus 1 over x minus 6 times x plus 1. So the x plus 1's cancel, and our final answer is x minus 4 over x minus 6. Remember when we write the domain to just use the LCD. So we end up with x equals 6 and x equals negative 1 as our domain restrictions. And our domain is x, such that x cannot equal 6 or negative 1. Let's take a look at complex fractions. Complex fractions are fractions within fractions. Complex fractions can be simplified by multiplying each term by the LCD. This will allow you to cancel out all of the denominators and you will just end up with one fraction. The long way of doing this is adding or subtracting the numerator, adding or subtracting the denominator, then rewriting the division problem as a multiplication problem, and multiplying. But trust me, the LCD method is a lot easier. So this first fraction is 2 minus 1 over x over x. So I'm going to make sure that all of these pieces are fractions. So I have 2 over 1 minus 1 over x over 1. Then I need to find my LCD. If I look at my denominators are 1, x, and 1. So my LCD should just be 1x, or just x. So then I'm going to multiply each of the little fractions by the LCD. So I'm going to multiply the first fraction by x, second fraction by x, and the third fraction by x. This will allow me to cancel out the x in the denominator of 1 over x with that x that I just multiplied by. So now I have x times 2 over 1, or just x times 2, which is 2x, minus, and in this term the x's have canceled out, so I just have minus 1, over x minus 1 times x, which is just x squared. And that is my final answer. Again, with the domain, you should always look at the LCD. Our LCD is just x, so our domain restriction is that x cannot equal 0. Number 10 is a little bit more complicated. We have 3 fractions all put together in one fraction. We have 1 over x plus 3 over 2 over x minus 3 minus 7 over x squared minus 9. Again, we want to make sure that we factor all of the denominators. So x squared minus 9 can be factored as x minus 3 times x plus 3. Then we need to find our LCD. That will be x minus 3 times x plus 3. So if we multiply each of the little fractions by the LCD, this will allow us to cancel out all of the denominators. Here, the x plus 3's cancel. Here, the x minus 3's cancel. And here, both the x minus 3 and the x plus 3's cancel. So in the numerator, we're just left with x minus 3 times 1, which is x minus 3, over, then you've got to remember to distribute here, 2 times x plus 3 is 2x plus 6, minus 7. So when we simplify fully, we end up with x minus 3 over 2x minus 1. So when we do our domain, we need to look at the LCD Then we also need to look at the denominator of our final answer. So we have 2x minus 1 as our final answer, so we need to set that equal to 0 as well. So we end up with negative 3, positive 3, and positive 1/2 as our domain restrictions. So our domain is x, such that x does not equal positive or negative 3, or 1/2.